Hello, it's Neutrino Ghost again here, and today we have a video for you on how to navigate using VORs. You can see I've written part 1. That means that this is going to be a multi-part video. The first part, which is the video you're watching now, is going to be a theory video. Another presentation similar to my TAF and METAR video. It's going to be a walkthrough really on how to navigate using VORs, how to fly towards them, and how to fly away from them. The second part, part 2, is actually going to be a practical demonstration, a video in flight which I've already made. And you can see here, this is the route that I took using the TNT VOR up near Derby, just north of Derby and just due east of Stoke-on-Trent. And the flight is simply from Alton Towers down here. It's about a 10-mile flight there or thereabouts, up to the TNT VOR and then back again. So you can see that in part 2. There'll be a link in the description to that. So let's get on with it. VOR, like everything in aviation, VOR is an acronym, and it stands for Very High Frequency Omnidirectional Radio Range. They are radio navigation aids, and their frequencies exist between 108 and 117.905 MHz. Don't be overly confused if you think that frequency range looks familiar. Part of the ILS frequencies exist between 108 and 111.95 MHz. However, part of the 100 kHz spacing have been reserved specifically for ILS. So don't think there's an overlap. Well, there is an overlap, but it's not an issue. They work by providing bearing information in degrees magnetic by phase comparison. I'm going to briefly explain what phase comparison is now for you. Effectively, the VOR on the ground emits a signal omnidirectionally. Omnidirectionally means that it emits a signal in all directions. That's what omni means. As I've said, there are two signals. One's called the reference signal and one is called the vary phase signal. And as the name suggests, one is a reference and one varies. And your aircraft then judges the difference between the two to determine what radial you're on relative to the VOR. As I've said here, how it works is that the reference signal maintains a fixed phase through 360 degrees, whereas the vary phase signal, which is the second signal, varies its phase by 1 degree for every degree that it rotates. So you can understand that if it varies its phase by 1 degree for every degree that it rotates, after 90 degrees it's going to be 90 degrees out of phase. After 180 degrees it's going to be 180 degrees out of phase, etc, etc. So the receiver in your aircraft compares the two signals, it measures the phase difference, and it derives a magnetic bearing of where the station is relative to you or where you are relative to the station. This is just a picture just to demonstrate. You can see here the top image. On each of the images we have a dotted line and a solid line. The dotted line at the top is the vary phase signal, and you can see that although the vary phase signal and the reference signal, which is the solid line, are in phase to start with, as we move clockwise around to the right we get to 90 degrees. And you'll see that due east of the emitter, we are now 90 degrees out of phase, because the vary phase signal is 90 degrees out of phase to the reference signal. Likewise at 180, 270, and obviously this works for every single degree in the circle. And by the time you get back to 360 degrees, they're back in phase again. Now, this is what they look like on the ground. You may have seen pictures of these taken from a ground level, or you may have even seen them flying and not really knowing what they are. This is what they look like if you ever fly over one. This one is actually the TNT VOR, which is what part 2 is based on. So I'm actually going to be flying over that one in part 2. On a map, that's what they look like. That's the symbol for a VOR. And that's the symbol for a VOR DME. A VOR DME simply means that the VOR is co-located with distance measuring equipment. So not only can you use the emitter as a VOR to locate your position relative to the VOR, but you can be slightly more accurate because you can measure distances. The DME becomes very, very useful when you're lost. It becomes very useful when you're flying from a VOR as well, which I'll mention a bit later on in this video. So here we have a map that I've scanned in of an area just to the southeast of Birmingham. You can see we've got Birmingham just up here. This pinkish area here is the southern part of the Birmingham control zone, and we've got Coventry there, Rugby and Daventry. You'll notice we've got two big circles on the map. We've got this one here, and we've got this one down here. This one is the Honley VOR. Now the VOR is actually this thing here. This small circle with the cross on it indicates that this is a disused airfield. Not overly surprising that we find the VOR DME actually located on the site of the old airfield, on the site of the old Honley airfield itself. And you can see here that we have the reference box telling us HON, that's the name of the VOR. The frequency of the VOR is 113.65, and it is a DME. It has a DME. I mean, you can tell anyway just by looking at the fact that it has a rectangle around it, but it's also nice to see it written just to make it clearer. And down here we have another example. We have the rectangle around the VOR symbol telling us that this is a VOR DME. It is the DTY, which is the Daventry VOR, frequency 116.4, and again, as we've said, it's also a DME. You may have noticed that I have, in this case slightly messy, I've drawn Morse code, dash dot dot dash dash dot dash dash here, and I've drawn the Morse code here. These are the Morse code identifiers, if you will, for each VOR. I'm going to explain very soon why I've done that. There we go. Right. So, we've gone over what they are and how they work, but how do you actually use a VOR to help you? Well, first of all, you need to tune in the VOR frequency into the required nav radio. So if we go back to here, we'll see, for example, if you wanted to tune into the Honley VOR 113.65, we'd locate our nav radio, which looks very similar to this in most training aircraft. This is a kind of a close-up, if you will, of this section here. This is the COM radio on the left and the nav radio on the right. So you take your frequency and you tune it into your nav radio. I won't say nav 1 radio because different aircraft use different electronics, but find your active nav radio and tune it in your standby, and then obviously hit the switch button and switch it to make it active. Next, this is very, very, very important. Once you've tuned it in, we can see in this example here, this is actually a picture taken from one of my photos that I took in flight. And we can see that the active frequency here is 116.8 and the standby frequency is 115.7. Incidentally, 115.7 happens to be the frequency of the TNT VOR, which part 2 is all about. 116.8, I believe, is the Shawbury VOR. So, in this instance, for whatever reason, we have the Shawbury VOR, which is the active frequency. And below it, we have this small round switch. Now, this actually is the on and off switch on a standard COM nav set. This is the on switch for the on dial for the nav radio. This is the one for the comms radio, and this is the one for the nav radio. You simply turn it to the right and it turns it on. Turn it further to the right, you increase the volume. You can see on this here we actually have a face on view, and it says there next to it pull ident. So what that means is that if you actually grab this dial and pull it outwards, you can actually identify the VOR. What does ident the VOR mean? Well, remember back here I said that I put Morse code signals on the map, I draw them. The reason is that when you ident the VOR, what you want to do is effectively make sure that the frequency you've tuned in is the correct VOR. You don't want to just tune in a frequency, assume that it's correct, and start following it. What you want to do before you do that is check it. You need to make sure that you're following the correct VOR so you don't end up flying through someone's busy airspace or flying off in the wrong direction, which could cause you a lot of problems. So what you do is you pull the switch outwards, you pull this switch outwards, make sure the volume's turned up, really important, and wait. Now, something in the region of 4 times a minute, you will hear the Morse code for that VOR. And the Morse code that you'll hear audibly will be the Morse code for the identifier for the VOR. So for example, this here dot 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 dash 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 dot is HON in Morse code. Likewise, dash dot dot dash dash dot dash dash is Morse code for DTY. So you want to listen to the Morse code and you want to make sure that you're tuned into the correct VOR. I'm going to give you a good demonstration now of exactly what that sounds like. This is a link to a Morse code translator on the internet. I've already got the page open somewhere. Here we go. It's called Morse code translator. You can just Google it. Let's put in HON. So that's the Honley VOR. Okay. What we're going to do is press play, and you are going to hear exactly what you would hear in the aircraft. Hear that? And again. So what you would do is pull the ident switch, make sure the volume's turned up, and then you would listen out. You'd ideally listen to it a couple of times just to make sure that you've definitely heard it correctly. Now this also explains why I've drawn the Morse code on the map, because it saves me having to A, remember Morse code, which I'd still recommend you do anyway if you can, and B, it saves you constantly looking on your kneeboard and trying to figure out, well, what is H, what is O, what is N, and then listening to it 5 or 6 times to make sure that it's right. If you've got it drawn out visually in front of you, it's much quicker, much easier to know that you've, well, it's just much quicker to decipher it. Let's put in TNT, see what that one sounds like. Nice and simple. Let's pick another one, DTY, the Daventry VOR. Again, it should sound like, we should get dash dot dot dash dash dot dash dash. Let's see what we get. There we go. And again, ideally, you'd listen to that a couple of times just to make sure that you've definitely tuned into the right frequency. Once you've done that, you want to locate an instrument in the cockpit called the OBI. That's the Omni Bearing Indicator. I've got a picture of it actually just up here. This is a picture of the cockpit of, I believe, the Piper Warrior that I fly. And this is the OBI up here. Okay? Should be very familiar to you. You'll notice it's always usually got a white triangle somewhere on the display. Not always, but it's usually located somewhere around there. Some aircraft have 2 of them, which is very useful. Usually located one above the other. Not always. Check your flight deck. You should see a couple of them around. If you've only got one, that's not rare by any stretch. A lot of training aircraft only have one. So, you locate your OBI. What you then do is turn this knob down at the bottom left-hand side. Could be on the right-hand side. And you turn it. Now, you want 2 things to happen when flying towards a VOR. And remember, this is flying to a VOR. We don't care about flying from a VOR yet. We turn the dial until the needle centers itself. Chances are the needle will be off to the left, it'll be off to the right, but when you turn the dial, the needle will start to move into the center. If you're flying towards a VOR, it's very important that the to flag is showing, because on the instrument, the flag can either show to or it can show from. Very important that if you're flying to a VOR, make sure the to flag is showing. And turn it, keep turning this the OBS dial until the needle is centered. Once the needle is stable and centered, read off the bearing given on the top of the dial and then turn the aircraft towards that bearing. Now, Step 5. Sorry about the grainy pictures, they're not the best ones in the world. Now I've said here, turn onto the desired heading and keep the needle centered. First thing you want to do is turn the aircraft onto the heading, the magnetic heading that the OBI reads when the needle is centered. Now, important to note that the heading will not necessarily match the bearing, because obviously the heading that you fly is taking wind into account. So let's try and picture this in your head. If you're flying, for example, due east, okay, your heading, your magnetic heading, no, correction, your bearing is 090. So let's say that you've got a VOR exactly to your east, 090. But if you've got a wind coming from the north, your heading wouldn't be 090. You've obviously got to fly with your nose into wind, so your heading may be 080, 070, depending on the strength of the wind. So what I always do is turn the dial until the needle is centered and there is a 2 flag showing. Then you turn the aircraft onto whatever heading the OBI tells you to fly. Chances are, if you have any wind, the needle will start to move at some point. And as you can see in this, the first diagram, I've made a note saying if the needle swings to the right, you move to the right. If the needle moves left, you move to the left. And what you end up doing is effectively playing cat and mouse. It's a bit of trial and error for the first 30 seconds, trying to take into account where the wind's coming from, which frankly you should know anyway, so that can aid you if you're already aware of where the wind's coming from, depending on the altitude you're flying. Take into account where the wind is, and then fly on a specific heading to maintain a centered needle. Okay, really important that the needle remains centered. It's not that difficult to do. Incidentally, I'll just point out, you may have noticed there's lots of dots on the OBI. Most OBIs, like the one you can see here, you have a central circle. The edges of the circle, where the circles meet the horizontal line, that's 2 degrees. Okay, each one of these dots is 2 degrees of deflection. So if you have a standard 5-dot OBI, you have a full scale deflection of 10 degrees. So in the left-hand image, you can see that the needle is to the right-hand side of center, and it's if you count the edge of the circle as the first dot, we have 3 dots to the right, which means that we are the aircraft, which effectively is in the center of the circle. The aircraft is 6 degrees left of the radial, or 6 degrees of the bearing that it needs to be on. So you would fly 6 degrees to the right. You would actually fly more than that, because you'd want to start all you do if you flew 6 degrees to the right, all you do is parallel your track, which is no good. You'd probably fly 10-15 degrees to the right first of all, until you saw the needle start to move back to the center. When the needle starts to approach 2 or 3 degrees, then you start to turn back onto your original or corrected heading to keep the needle in the center. It stops the needle swinging left and right for 2 or 3 minutes, and you just chasing it. Once you approach the VOR, as you can see from this diagram, I've said within 50 degrees. Just point out, incidentally, a lot of text that I've seen on the internet uses the term 40 degrees. That's incorrect. It is 50 degrees. 40 degrees tends to be things like NDBs. But VORs, what I'm about to talk about, the cone of confusion as it's called, is definitely 50 degrees for a VOR. When you approach the VOR, the needle becomes erratic and unreliable, and as I've mentioned, this is called the cone of confusion. It also goes by other names as well. It's very simply because you are now directly above the beacon, and your aircraft cannot pick up a strong enough signal to determine where it is relative to you, because it requires some form of moderate slant range in order for it to pick up a decent signal strength. So if you're virtually directly overhead the beacon, then you're not going to pick anything up. At this point, you're going to get a warning flag on the OBI. Okay, your needle's going to be swinging left and right erratically. It's going to become extremely sensitive. You should note if you've got a DME, and you should see on the DME that you are probably within half a nautical mile. again depending on your altitude. For general aviation, you'll probably be somewhere between 2, 5, 6, 7,000 feet, in which case probably anywhere within less than I'd say about half a nautical mile you're going to be experiencing this. You know at that point you're virtually overhead anyway, nothing to worry about, but the needle will become very erratic, become very sensitive. The to flag and the from flag may temporarily disappear, and you will get usually a red warning flag or a red and yellow striped flag, or you'll get some kind of warning visible on the display. Again, watch part 2 of this video. There's a practical demonstration of that actually happening as I fly over the TNT VOR. On the right hand side I've given you the equation, no idea if you need it, but it's R, which as we see in the diagram is the radius at which this cone of confusion becomes noticeable. In nautical miles is simply the height in feet multiplied by tan of 50 divided by 6,080. If you want to know where 6,080 comes from, it's just very, very close to the number of feet in a nautical mile. And because R is in nautical miles and height's in feet, we need to maintain the same units. So you divide by the number of feet in a nautical mile. Right. Flying to a VOR is not difficult. Flying from a VOR is just as simple. Step 1, you tune in the nav radio to the desired frequency, exactly as we did before. Step 2, really important. The most important thing you can probably do is ident the VOR. I'll point out now, if you are a student PPL and you go on your skills test and you don't ident the VOR, I'll be staggered if you pass. Really important that if you are flying in an area that has VORs and you are using VORs on your skill tests, I'm aware that some people don't, depending on where you learn. Not everyone has access to VORs near their airfield, which is one of the reasons I'm making this video. If you are using them on your test, please, whatever you do, don't forget to ident it. Step 3, turn the OBS to the required bearing and look for a from flag. Now remember, when we're flying to a VOR, we turned the OBS until the needle was centered and we had a to flag. If you're flying from a VOR, just keep turning the dial until you have a from flag. Once you have a from flag, keep turning it until the needle is centered, and then follow exactly the same procedure as you did for flying to it, and simply keep the needle in the middle. You can see here on this diagram on the right hand side, good example, there's your OBI, OBS is your dial to the bottom left. We can clearly see that we have a centered needle. This one is on a radial of, what's that, 253, there or thereabouts, and we have a from flag. Now, I've given you a picture here of the route I took during part 2 of this video, but just to kind of give you an idea of how you would use a VOR to fly from a VOR. Let's assume that we are coming from up here somewhere. We're coming here and we're flying due south towards the VOR. We're tracking to the VOR, so we've got 180 set in the OBI, and we have a to flag. And we're flying towards it, we're flying towards it, we're flying towards it. And we know that we want to turn right, overhead the VOR, and we want to head over to Alton Towers, which is down here. How do you do it? Well, what you would do is measure this radial. You can see we have this this arrow here pointing up. This is magnetic north. Now obviously the angle of this is going to change depending on where in the world you are, depending on your magnetic variation. But where we are, you can see that magnetic north is very closely aligned to true north, which is directly up the page. You measure off this angle clockwise to there. So here we can see that's magnetic north, this arrow is magnetic east, this is magnetic south, and this is magnetic west. So we can see here that we've got, this is 270, this is 27, this is 26, this is 25, this is 24, so it's about 247, 248. Let's call it, yeah, let's be accurate, let's call it 248. So the first thing you would do is know this radial. You have to know this radial in order to fly from a VOR, because you only use a VOR if you're flying from a VOR to get to some location. So if we're flying south towards the VOR, at about this point here, sometime before it, already knowing that we're very, very close, or perhaps using a second OBI if you have one, you would turn the OBI using the OBS until you have a from flag, and you would turn it until the top of the dial, this bit here, reads 248 in this example. And then you would simply turn right, and you wouldn't want to turn too sharply because you're going to miss this line and head over here somewhere. What you want to do ideally is try and intercept this line somehow. So you make a shallow right turn onto something less than 248, maybe 230, 220, and you'll notice that the needle will start to move towards the center as you start to intercept this line. As you start to intercept the line, continue your turn to the right until the needle is centered, and then you just follow it out. And you keep flying, like in this example, with a nice centered needle, knowing that the VOR is behind you, you're flying on your radial, and you have a from flag showing. Now ideally, what you would also do is measure the distance from the VOR to the object in question. Now I know that the distance between the VOR and Alton Towers is, as near as makes no difference, is 9 nautical miles, to within a few hundred yards. So what I would do is, upon passing over the VOR, I would look at my DME. My DME should be reading about 0 because I'm directly over it. If anything, the DME might not actually be accurate. You might get a warning somehow. And then as you fly away from this, if you have a DME, of course, we can see that this is a DME. Remember, we have a rectangular box and we have DME written in the reference box. Once we've measured this distance, we just keep flying, keeping the needle centered, and then keeping an eye on the DME. When the DME reads a set distance that we are expecting it to, again, providing that we're using the OBI correctly and providing that the needle is centered, when you reach your set distance from the VOR, you should be directly overhead the ground feature that you want to be on. And it does work. It works extremely well. Again, see part 2 of my video, and I give a very good practical demonstration of how that works. A couple of things to note here. 3 things actually. One of them I think I've already mentioned. The first one is that the OBI will only give you bearing information. Okay, it doesn't give you heading information. The VOR is a fixed object on the ground, and as we've mentioned, it's aligned with magnetic north. So depending on whether you're flying to it or from it, your aircraft will only tell you where the VOR is relative to you, relative to the aircraft. It gives you no heading information whatsoever. Really important to note that. The heading that you need to fly to a VOR or from a VOR is purely wind dependent. If there's no wind, then your heading will match the bearing that the OBI states. If you do have a wind of any strength, or unless it's extremely light, then your heading will not match the bearing. That's something you need to take into account. Again, part 2 of my video, I demonstrate that moderately well. Kind of repeating myself here. When flying to or from a VOR, your heading will only match the bearing selected on the OBI, assuming no wind. Sorry to repeat myself, but it is actually very important, as you'll see from part 2. And finally, be aware of reciprocal headings. The needle will swing in the opposite direction. Okay, what this means is simple. If you are flying to a VOR and you haven't checked the to flag, and you've centered the needle and you've actually got a from flag, you might still have a perfectly centered needle. Now, if you do have a perfectly centered needle, chances are you won't have any problems. Assuming that you are flying correctly. If it's just a cock up on your part that you didn't check it, as long as you know from ground features that you're heading in the right direction, you should still get to where you want to go. However, the problem comes in if you're flying in unfamiliar territory with very few ground features, or if you're flying in poor visibility. If you start dialing in the wrong bearing information on the OBI, you'll find yourself in a lot of trouble. You'll know you're in a bit of trouble if you've got the reciprocal heading set, i.e. you're flying on the radial instead of the bearing, so you're flying in the wrong direction. Because when you're flying to a VOR or from a VOR and everything's set up correctly, if the needle moves to the left, you need to move to the left. If the needle moves to the right, it means that you're drifting left and you need to turn to the right. So you always in effect have to follow the needle, and as you follow it, the needle should recenter itself. However, if you set the OBI up incorrectly and you're flying on the reciprocal heading, you'll note that as you turn to correct your error, you'll make the problem worse. Okay, so as the needle drifts to the left, you turn to the left. But as you turn to the left, the needle goes more and more to the left. And you turn more to the left, it goes even more to the left. And before you know it, you're on full scale deflection. Once your needle's on full scale deflection, you have no idea how far out you are, because the needle only goes to 10 degrees full scale deflection in most cases. And as long as that needle is constantly on the 10-degree line, then you should start questioning, what have you done wrong? And likewise, if your needle moves to the right and you move to the right, and the needle continues to move to the right, first thing you need to do is check the OBI. Make sure that you're not flying on the reciprocal heading. Check your to and from flags. Really important. I have admittedly made that mistake myself about a year ago. Thankfully, I was in the middle of nowhere and it wasn't an issue. But if you're flying to or from a VOR very close to congested airspace, you'll find yourself in a lot of trouble. So, not sure if I rushed that. Apologies if I did. I think I covered it in a relative amount of detail. And click here for part 2, and you should be able to see me flying a VOR exactly as we mentioned on that map, from Alton Towers to the TNT VOR and back again. Any questions, please don't hesitate to ask. Thank you.